Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Today we will cover on the last topic of modeling computation, which is finite state machine with no output or without output. So the lesson outcome actually same as what we have in 6.2. We need to know how to draw and construct the state diagram and the state table for the finite state machine without output, and also to determine the languages recognized by the finite state machine without output. So first of all, what you need to know is you need to know the definition 1. So suppose that A and B are subset of V star, where V is a vocabulary, means V star is a word, any word generated by the vocabulary of V. So the concatenation operation of A and B denoted by AB is the set of all strings of the form XY, where X is come from A and Y is a string come from B. So let's go for the example. So for example, you have A equal to 0 and 1 1 and B a set of 1 1 0 and 1 1 0. It asks you to find AB and BA. Means it asks you to find the concatenation operation of AB and BA. So AB and BA will give you a different answer since the set of A and B are different too. So I just show you how to get the concatenation operation of AB, and I hope so that you will do as exercise for the BA. So AB means you put A first then B. So how you get this kind of answer is by combining the A and B, the element in A and B. So you will get 0 1 0 1 0 0 1 1 0 1 1 1 1 1 1 0 1 1 1 1 0. So you get the AB. Okay, so I hope so that you try for the BA. Extended from definition 1, previously we have an, where for n 0 1 to until infinity can be done recursively by specifying that the first the a0 is equal to the empty set and the an plus 1 in a power n plus 1 is actually a power n concatenation operation with a. Here is 1. Okay, if it is here is 2, so mean 2 plus 1. Here is a2 a which is a1 for n equal to 0 1 to until infinity. So we go for the example. Let a equal to set of 1 and 0 0. It asks you to find the a power n for n 0 1 2 and 3 only. So you need to find n0 when n is 1, when n is 2, and when n is 3. I just show you until a2. I hope so that you try for the a3. Is it you got the same answer here? So a0 for all power of 0 is an empty set. Okay, or we denoted by lambda. A1 is actually here, since here need to be 1, so this one is 0, so a0a. So what is a0? Empty set. What is a? A is actually a1 and this is a, so this is empty set, so the answer is 1 0 0. Empty set means nothing. A2 means here should be 1, here should be 1, so A1's concatenation operation with A. So A, so you will get 1 1 1 0 0 0 0 1 0 0 0 0. Okay, please try for A3 and you will get this kind of answer. Next, we have definition 2. The definition 2 say that suppose that A is a subset of V star, mean A generated by some of A is a word that generated by V, but it's not covered all. Okay, so then the clean closure of A denoted by A star is the set of consisting concatenation arbitrarily when it's string form of A. That is actually A is a subset of A star is the subset of B star. So we go to the example. What are the clean closure of the set A? 0, B given as a set 0, 1, and C 1, 1. So this is the final solution. Can you try first before you go to the solution? Okay, how to solve this? To solve this, when you want to find the clean closure, what you need to do is you try to find the concatenation operation of A. Start from A0, A1, A2, A3, and you see the pattern. So if it has a pattern, we conclude as a general. If it's not a pattern, we will answer as what we have as in B. So let's go for the example 1. What are the clean closure of the set A, which is 0? So you know that given A is equal to 0, you need to find the clean closure of A, which is A star. So A0 is empty set, A1 is actually the combination of empty set A0 and A, so empty set with 0, so 0. A2 is actually the concatenation operation of A and A, so 0 and 0, so you will get 0, 0. A3 is actually the concatenation operation of A2 and A, so you will get A2 as a 0, 0. You concatenation operation with A, so you will get 0, 0, 0. So from here, okay, we can see it has a general form. Okay, if it is A is 1, it just have 1, 0. If it has N is 2, it has 2, 0, 3, 3, 0. So we see that this pattern, so we conclude that A star is actually equal to 0 n, and mean the power, where n is start from 0, 1, 2 until infinity. Why I put start as a 0? Because we have, if it is n is 0, means there is no repetition of 0, so mean empty set, so it cover for A0. If it is n is 1, so means you just have 1, 0, so it's cover for A1. Okay, so this is the second example. What are the clean closure of the set of B0, 1? So again, we do the same thing. Okay, we find the B0, B1, B2, B3, the concatenation of operation of B. Okay, but here you see that B1, B2, B3, there is no pattern. It just consists a word of 0 and 1. So we can say that B star is actually V star, where, or you can say that B star is actually all string over 0, 1, or all string generated by 0, 1. Okay, both answers are acceptable. The third one, what are the clean closure of the set C, which is consists 1, 1? So again, we do the same thing as what we did in example 1 and 2. So you see that C1 is actually C0C, so you combine the empty set with 1, 1, so you got 1, 1. C2, you combine the C and C, so you have 1, 1 and 1, 1, so you got 1, 1, 1, 1. So when you do for the C3, you got 6 tuple of 1. So you see the pattern here, 2, 4, 6, repetition of 1. So you can say that C star is actually 1 power n, where n is 0, 2, 4, 6, or you can say just 1 power of 2n, and start from 0, 1, 2, 3. So if it is 0, means 1 power 0, no repetition of 0, it represents the C0. If n is 1, mean 2n, 2 times 1 is 2, so 1 is repetition 2 times 1, 1. If you use this, just substitute with 0, means no repetition, it represents the C0. If it is 2, means you have 2, 1, 1, 1, so it represents the C1. Okay, both answers are acceptable. I hope that you are very clear with that, and I hope so that you try for the exercise 6.3. Okay guys, now we come to the finite state machine with no output or without output. Okay, previously we covered on the finite state machine with output. So all the finite state machine without output we call as a finite state automata, but if it is singular we call it automaton. Okay, this finite state machine doesn't produce output, so it has a final state, so it's different from the finite state machine with output, and you don't have the final state. So We can recognize the difference between the state diagram of finite state machine with output and without output if we see the double circle. Mean if you see a double circle, that machine is a finite state machine with no output. Okay, the double circle represent on the state. Okay, the recognized string that take the starting state to a final state, that is the only language narrated by that machine. So if it is a finite state machine with output, you have 6 elements where you have G, the transition function output, and also O for the output. But for the finite state machine with the output, you just have 5 elements, which are S, I, F, S node, F. This is state, this is input alphabet, this is transition function input. You have your initial state here, S node. Sometimes in the equation is not represented by S node, so you need to refer here. Okay, F is a final state. Okay, so also with the finite state machine with output, you can represent the machine by using state table and state diagram. Okay, so now these two represent the same machine, but this one is represented by using state table and this one by using state diagram. So if you see here clearly the difference between the finite state machine with output and without output. In finite state machine without output, you just have 2 columns. Did you remember? In the finite state machine with the output, you have 3 columns, which you have the transition function G. So now for the finite state machine without output, you just have 2 columns. You have state, you have the transition function F. Okay, this is your input. All the numbers on the edges here represent input. Okay, because there is no output. Means if you have a comma here, S2 with input 0 go to S0, S2 with input 1 also go to S0. Okay, so how to read this state table is same as what how you read the state table for the finite state machine with output. So you will read S0 with input 0 go to S0, S0 with input 1 will go to S1. So we can check from here. Okay, S0 with input 0, is it go to S0? S0 with input 0 go to S0, so it's correct. S0 with input 1 go to S1, S0 with input 1 go to S1. So since it doesn't mention here what is your initial state, so you will see that from the state diagram the initial state is S0 because the arrow in. Okay, and it mentioned here your final state is S0 and S3. That's why the S0 and S3 have a double circle. So any language generated by this machine will just consider by the one that go to the final state. Okay, we need to start from the initial state and stop at the final state. This finite state automaton is called deterministic because for each pair of state in the input value there is a unique next state. Okay, unique. But if I have, for example, S node with input 0 will go to S0, S2. Okay, so that one is non-deterministic because with one input it goes to the 2 different states. Okay, so that is the difference between deterministic and non-deterministic. But how to draw, how to construct the state table is same. Okay, I hope so that you try from here to here and also from this state diagram to this state table. Okay, if this one to this one is not unique because it based on the location of your how you put your state, but from here to here it must be a unique one. Okay, please ensure that you will sort the state accordingly based on the alphabetical order. Okay, so this is your exercise 6.3. You need to construct the state diagram for this state table. Okay, you see here it is mentioned about the final state, so please ensure that you have a double circle on S node and S3. Also for the table 2, it just double circle for S node And it doesn't mention about the initial state automatically. For both exercise, you need to start with S0. This one is you need to construct the state table for the standard machine of M1 and M2. So you can create one state table for this one and one state table for this one. So please ensure you just have 2 columns. Since you have a double circle, mean it is a finite state machine without output. Okay. And the second one, please ensure that you put under the table what is S, what is I, and what is F, to ensure that you get a full mark. Okay, we go to the last subtopic, which is language recognition. Okay, if it is a finite state machine with output, you need to draw a table where you have the input state output table, but here you need to see the one that goes to the final state. Okay, so we can say that two finite state automata are called equivalent if they recognize the same language. If it generated the same language, so we can say that the finite state automata are equivalent. Okay, so to do exercise 6.4, so let me discuss for both example. Okay, so you will see from here the initial state of M1 is S0 and your final state is S0 and S2. So we will focus only the language that generated by this machine that goes to N as node and S2 as the final state. Okay, so it different from S2. You need to ensure that you focus on S node and S3. Okay, let's go for the M1. So you see here the final state is given by S node and S2. So we need to list first before we make a conclusion. Okay, so if it is S node is a final state, the language generated just empty set because it's directly for initial state. Go to S node, it's already final state, so the answer is empty set. But there is no more language other than empty set that goes to S0, so we need to focus on the S2. So you see that S2, the one that goes to S2 is either, the first one is empty set 0 1, so empty set is nothing, so 0 1, or maybe it just can go 1 here. Okay, it just can go directly 1, so you have 0 1, okay, or 1. Is there any language generated by this machine that end on the S2? No, because if you go here, it doesn't have any arrow back to S2. Okay, so only 0 1 and 1. So you see that this one all are different, so we can conclude that the language generated by this machine is given by empty set 1 and 0 1. So this answer is unique. Okay, means it's not a general one. But if you see in M2, okay, the final set given is S0 and S3. Okay, so we need to focus on the language generated by this machine that end on the S0 and S3. And you see for the S0, it is empty set. The second one, it can be as a 0 0 0 0 0 0 repetition and time. So we can denote as 0 power n and start from 0 1 2 3 until infinity. Okay, because this one is new, we don't have any limitation. So there is no more language generated that end on S node, so we need to focus on the one that end on S3. So in S3, okay, it has many possibilities. The first one, either you have a loop here, then you take 1, then you take 0. Okay, so that's why you have the L3M for the machine M2. Or maybe you can have 0 and repetition and time 1 0, and then you have this kind of loop. 0, 1 means you can take as a 0 or 1 as the input, either one. So it can be 0 and 1 0 0 m time, or maybe it can be 0 and 1 0 1 time of m time of 1, or maybe it can be 0 and 1 0 combination of 0 1 m time. Okay, so n m can be start from 0 1 2. The third one, maybe the language generated can be 1 0. Okay, the fourth one, maybe it can be generated as 1 0 repetition of 0 1 n time, that represent by L6. So if you see from here, okay, so since there is no more language generated by this machine that end on the S3, okay, we just see that there is 4 1 2 1 2 3 4. Okay, so we see from here this empty stack is actually here. Why I say that? Because if n is 0, there is no 0 mean it is empty set. So since it's here, we can just cross this one. Okay, we don't want the one that is redundant, so we just consider L2. And in this case, you can see clearly L3, L5 and L6 all in L4. Okay, why I say that? If m is 0, okay, it will give L3. If n and m are 0, it will give L5. And if n is 0, it will give L6. So L3, L5 and L6 are in L4. So next, what we need to do, we cross the L3, L5 and L6. Now what we have now is L2 and L4. Is it L2 in L4? No, because in L4 it must have 1 0. So means we need to combine these two. So the language generated by this machine is 0p. I just changed this n to p because I don't want to make you confused with this n. Okay, so this one we just remain the same, n and m. This one I just change with any other variable, which is p. Okay, so the combination of this one and this one are actually the language generated by this machine, where m and p start from 0 1 2 until infinity. So I hope so by this explanation you are clear with the language generated by this machine. So this is an extra exercise that you can refer to page 814, 815, 816 and 817 in Rosen KH book online. That's all. Thank you.